Gentlemen, we have a Sweet 16. It's in really good shape. This one's got a fan kit on it and everything. This gentleman, we're going to refer to him as Mr. K. Mr. K sent this to me, I hate to say it, 18, 19 months ago. And what has happened with Mr. K's box is he's let out the magical 10 ohm smoke on that transistor, that transistor, that transistor, that transistor. He got it too hot. We're also going to look down here at this resistor here. It's burned up. And obviously this resistor here is burned up. But the other two transistors up here in the front, they're still good. Now, that being said, we're still going to replace this resistor here and this resistor here to make sure they're all in the same tolerance. But he caught that he had a problem before it turned into a real problem. Because this combiner is not discolored, nor is this one, and usually they turn into refried dog poop. At least this one does. We try to key him a bunch of times. The other thing we got to do is we got to secure his relay. That's no effing good. So we'll unsolder all this mess. That and there's some questionable shit going on here with the relay. We'll unsolder everything here. We'll put some automotive commercial, BHV, double-sided stick tape to hold this thing down. We'll remount everything down. But yeah, this style of Sweet is what motivated me to start changing how I did things. Please note there's no fuse holders back here, right? They knew that this was a problem before you all knew this was a problem. They started going to heavier gauge wire. And then they've got it directly summed into an Anderson clip. This is the way they started coming factory. So this here is stock. And this here is adequate-ish. We're going to make it adequate, period. So we'll pop this out. We're going to remove these two smaller power wires, even though technically this isn't even the right kind of wire. We're going to go ahead, we'll pull this single piece of 8 gauge out of here. We'll replace it with 4 of a single piece of 4 gauge come in. We'll probably put a distribution bar over here. You know how I like to do it. We'll change this out, hand tie it, making it look all pretty. And I'm telling you, brother, you've got the sweetest wife on the face of the earth, Mr. K. She called me and we've been talking, and was out of town last week when she reached out and contacted me, and I said I'll get back to her on Friday. I wasn't able to get back to her on Friday because I was still driving. And she contacted me yesterday, and we've had a great conversation, and she is a good person. Good person. And I appreciate her reaching out. But enough talk, more do. Let's strip out these 4 pills. Now he's opted to put Toshiba's back in here, so that means we get to leave these front 4 alone, and we just got to twiddly fart around with these back 4. So is what a TI is. Let's do our McNasty. Well, it worked out why it blew up. God. The devil is in the details, Texas Star. The devil is in the details. So I went to undo these 2 transistors, and that pill tab and that one were down tight. These 2 were not tight. And then I come to the back ones. This one was loose, that one was tight, this one was loose, and that one was loose. It's still got the fingerprints of when they wiped the cream on the bottom of the transistor. So it blew up because they didn't bother to tighten down the transistors to the heatsink. The front four, on the other hand, were tight. So either this was made on a Monday morning when the two Asian gals that have been making these for the last couple decades have been drinking all weekend, or it was on Friday night and you're getting ready to clock out in 10 minutes. I don't know. Pills weren't tight. See, normally when a transistor comes up, it looks something like this. You see the difference in the pattern in the thermal compound? Or like this. Or like that. This is where literally somebody took their finger with a rag or something on it, went and wiped the thermal compound on it, and it was only making contact on that one ear, this ear. Because that heat sink, it's friggin' spotless. Damn it. I'm gonna rebuild this relay connection. I got the relay mounted now. It was just in there floating, which is really hard on this relay because it spends most of its life hanging upside down. It's magnetic driven, not spring driven. To have that floating around and having that extra vibration added to the system is no good. So anywho, we took this VHB tape, we mounted it down. Today was an interesting day for me. Me personally, I spent all day tearing my own personal truck apart. So I did that 48 pill for myself, which took a year to build. I was going to do a YouTube video on it because I do a YouTube video on, like, it seems like everything. I just want to be done with it, if that makes any sense. So I got it all done. No YouTube video on that, by the way, you guys. And I decided that I was going to go test it. I mean, like, right, really? And I took it on the road trip that I did the weekend before last. And then, that'll work. Then I came home and I worked some bugs out on it, and I actually went to go use it. Well, I was kind of coming through the speakers in the truck just a little bit, and it didn't really dawn on me what was going on there. I just went ahead and got really excited because I had my big linear in my truck and I'm happy, and I'm gonna get to go play with my linear now, right? So I go out and I get in the truck, I drive over to the park, I got the station over here recording myself so I can hear what I sound like, and I go to fire down. And I made about 5 or 6 keys, and I'm looking over at the passenger door. I'm in the driver's seat, and I'm looking over at the passenger door, and smoke starts coming out of the corner of the door by the window. I'm like, I don't know what that is, but that can't be any good. Now, I was kind of coming through the speakers like it was a roll. I didn't think anything about it. This was a mistake. It wasn't going to take till the day to fix this mistake. Well, it was really important to me to get this test out of the way to be able to talk on my radio more than the stereo. You know, I'll drive around in silence. By the way, all 4 good transistors installed in here. So I thought I would just chill and go talk on my shit. Well, the smoke later on that day presented itself. Like, I came home all full of confidence because I got good swerves, good reflect, and everything was running really good. Forward power's really good. I'm satisfied with what I've got, right? And no, I'm not driving it very hard. I'm not driving the 48 pill. I'm hitting it with a friggin' 4 pill. Let's go ahead and take these burned up bias resistors out of here. Well, I didn't think anything about it until later that day when I went to hop my truck to go run an errand, and I reached down and turned on my stereo. And all I hear is it's all subwoofer. And I went, oh no. So this is a guy that figured out how to make a 64 pill work in a truck that had 50,000 watts worth of just sub-amplifier power in it. It's not that hard. You got to have one on or the other. Stereo on or radio on. You don't get to have both on. That's never going to work. We're replacing all of the 1.8 ohm bias resistors. Whenever I have a pill pop, it's the transistors are so expensive anymore. Resistors are cheap. Obviously, when you blow a pill, you're going to blow that bias resistor up. This has cost a lot of people a lot of money over the years because they don't know to check this little 1.8 ohm resistor. When the transistor goes open, the 12 volt that's present backs up. It smokes this one little resistor that goes to ground. And the next thing you know, you got 12 volts getting dumped on your input transformer, and that's it. Game's over. Pills are dead. That's it. So, word to the wise, if you blow your pills in your Texas Star, you need to change the little resistor that sits right here on the board, and sits right here on the board, and sits right here on the board, and sits right here on the board. You'll thank me later. Anyhow. I'd rather change all of these resistors, honestly, than... There's this thing called tolerance, right? So parts are manufactured to a tolerance, usually like 3 to 5%. Most of the time it's 5%. Well, I got 1% tolerance resistors, and this resistor is the only thing that dictates how much current the transistors can pull. This is what controls your bias. And me personally, oh come on hands, only done this 100 times. Me personally, have no problem spending 0.2 of a cent. I'm all butterfingers tonight, look at that. Sorry about that, guys. I just dropped my ball of solder and then proceeded to drop my microphone. I'd rather spend the 0.2 of a cent, you know, because you can buy a packet of 500 of these resistors for like $3. I'd rather change out all the resistors than have to explain to myself why I took such a huge loss with me burning up components. Because it doesn't take much. These two resistors could be a little bit out of tolerance from these two resistors. It's going to cause this end of the amplifier to act differently, and you're going to have a heating issue in your combiner circuit. So let's just replace them all. So I turn my stereo on, I go to run an errand, and I come to a stop in front of my place. I'm like, son of a bitch. And I immediately knew what happened. Basically what it was is I'm an idiot, yo. The stock amplifier for the truck, so your head unit puts out like 10 watts maybe per channel max, right? Well, your stock head unit puts out that 10 watts. Well, it in turn goes to an amplifier that's got a high level input on it. Well, that high level input is in an amplifier, and that amplifier kicks it up to like 20 or 30 watts per channel. Well, my 4 doors on my truck, all 4 of them smoked. The stock amplifier stayed on that entire time. And as I was out there talking, it was burning up the amplifier inside the truck. The stock amp was completely fried, and 3 out of the 4 channels had completely opened up and gone to ground, and was dumping DC voltage directly onto the speaker coils and fried 3 of the speakers. Okay, well, when the amp went bad, that means now I'm going, shit man, I gotta go on like a 2,000-mile road trip the day after tomorrow, like the next day. And I thought to myself, well, in my myriad of shit I have around here, I know I've got a little, 4-channel, probably 150, 200 watt amplifier, so it's doing about 50 watts per channel. And I just assumed that it was just the amp. Assumptions, the mother of all F-ups. So I know that stock amplifier is in my center console. I know this because I had to take my entire truck apart when I first bought it to put all my radio shit in it. And I've got all my radios hidden in my center console, and my audio processing and all that shit's in the center console of the truck, and I had to move that stock amp around a bunch. So I go in there and I pull that stock amp out and I replace it with an Alpine, what they call rail amplifier. And I'm all good to go. Turn the stereo on. Now I've got my front tweeters working again. I don't know why they didn't blow up. I guess the crossover must have blocked the RF. My front tweeters now work, which was hopeful. The front 2 speakers work, but they're a little distorted. I'm like, okay. I can work with that though. The rear 2 pillar speakers, which are married off the passenger rear door speakers, they worked, but they kind of crackled a little bit. I'm like, I can live with this. These are livable things, right? This isn't like, I can handle a little bit of speaker not sounding perfect. Just a little bit. Now please note, the amplifier that I put back in the truck is obviously now on a switch that is controlled by the head unit. So I turn the head unit off, all the speakers are cut off, and the output of each one of the speakers for the amp, I wrapped around one of these ferrite rods. So the amp's output comes across a piece of type 43 like this and is tightly wrapped all the way down the length of this rod, making a big choke. RF can't get in, RF can't go up, out on those lines, which is good. These are good things. So I went on my road trip and I put up with it, and it was slightly annoying because every time my guy in my Audible book that I was listening to would say S, you could hear the left rear speaker go. It's slightly annoying, but it wasn't like, okay, riding around in silence. You know what I mean? Because, we've had some good skip here lately. Don't get me wrong. But my luck would be I go to get in my truck and I'm not going to have any skip. That wasn't the case. I ended up spending most of Friday talking on the radio and most of Wednesday talking on the phone on the way over there, which worked out. It all worked out. So I got home and I said, okay, this is one of like 15 things I got to take care of in the next couple weeks. I'll get around to it when I get around to it. Well, today I'm out there wiring that rail amplifier in, and it is 20 degrees, 35-mile-an-hour winds, and snowing. This is last week, you guys. This week, today it got up to a high of 75 degrees, sunshiny, no wind, beautiful out. I got up this morning, I put me on my pair of shorts for the first time of the year. I'm not going back. I'm going to wear shorts until winter, or it gets cold again. because I like shorts. I freaking hate pants. I put on some shorts. I went outside. I took my doors apart. I figured out what adapters I needed because the speakers that were in my truck were Bose, and I was going to Alpine 6.5s. I went and I got the adapter kits. So I went from like 5 1/4s to 6.5 speakers today. Got a little bit bigger speaker. I put coaxials in there instead of components, which just the smallest things make me happy. I am pretty deaf in the high-end range of things from all my years of doing car stereos and guns and all the other crazy shit I've done in my life. And I got 4 fully functional speakers, 1 in each door. I replaced my pillar posts in the rear, and I replaced the tweeters that were up in the pillar posts up above the dash. And it sounds phenomenal. Okay, so it's been fully power wire upgraded now. It's got 4/0 gauge feeding it instead of 6. It's all pro modded up. And we just plugged it in. I have no idea what this is going to do. Hello, 1 2 1 2 1 2. Okay, pass-through tune looks good. Oh yeah, this thing's gonna run like a raped animal. We're on 13 volts, as you guys can see here. This is a 1,000 watt slug in peak, 1,000 in average, 5 watt slug in reverse. And I just drove this with about 20 watts worth of power. It's making 900 watts output. Let's image mode thermal. That output combiner is nice and quiet. All the transistors are firing on the right scale. Let's make sure our voltages are right. Our input transformers, and then we're good to run it on up. This is the improper way to measure it, but it is what I call dirty. Quick and easy. Okay, 5.24. Not too bad. Okay, not too bad. Not too bad. Okay. The proper way is to measure that current that is flowing to each section, but it takes too long to set up. So me being me, it took a couple minutes and memorized what I need to see on the voltmeter in fluctuation to know that I'm in the right class of operation of class A, or class B, pardon me. You only get into class A or AB, it's nothing. These aren't AB1. Tubes are the only thing that can really achieve AB1, or certain different modes of operation in FM only. Class B. So, yeah. So let's go over here real quick. 1,000 in peak, 1,000 at average, 5 watt slug in reverse. Drive power. And to make that 800 watts of power with 20 watts of drive. Pulling about 80, 90 amps. So let's go ahead and let's turn the voltage up a little bit. Let's get this out of the field of view for right now. The old octopi, I'm gonna send that back. You might have a use for that. Okay, so now we're around 15 volts. Let's turn the amp off. So under 15 volts of power, 25 watts, put a couple more watts in it. But how the box works now is going to dramatically change. See that? back this out a little bit. Hello. That is with the 2950 up here driving it. So now let's go over here. We'll look at the 5-watt slug back in reverse. Hello. I'll take that any day, all day long. And it's making, let's say about 1300. Let's see. So this hash mark here, this big hash mark's 1000. The 60, 30, 15 line is 12, 14, and so on. Right at about 1300 watts. Now you got to ask yourself, how much time? The only way to really read a bird meter is to look at it straight on. If you're looking at it at any kind of angle, it can lie to you, especially if you're counting every single freaking little millifart of watts. So like I said, this hash mark here between the 40 and the 60 is 1000. The 30 and the 60 is 12. And the next big hash mark there is 14. How much time does a guy have to look at a bird meter operate to tell how hard it's slamming in the corner to be able to guess what it's doing on up? 13 on the money. Just saying. Just saying. Might have spent 5 minutes out here looking at this stuff for you guys. I don't know. Maybe. Just. Okay. We're done with the little radio. Let's go ahead and hit this with the D-Rail Striker 955 Super Hot Rod radio. The other hand will turn on this radio, turn that radio off, and turn that on with this hand. Grab this microphone. Hello, audio. Okay, so now we're down on 2X. Let's go to 1X. Let's go on over here and look. Hello. About 150 watts. Which is just about where you want to run this thing to see the box live forever. Back to 2X. Hello. Beautiful. So we're seeing 1000, 12, 14, 16, seeing about 17 out of this. Hello. 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 A little bit over, a little bit under. Hello. 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 So now what did I just say? If you're not looking at the bird meter straight on, it'll lie to you. Let's come over here to my point of view, where I've got to stand because of the camera. Let's look at the bird meter run. Ready? Hello. 17 from over here. Put that on. 1650. Hello. Okay. It's all about the perspective. All about the perspective. That's it. Let's see here. Full power wire upgrade. Now what we did do is save you. And what I mean by that, make sure everything's still nice and golden. Oh yeah, everything's running just the way it should. There's no lying to this. You cannot lie to this meter. Right there is our bias resistor. There's our flyback resistors. This is our first stage combiner. And that's our final stage combiner. We see any heat where that little bullseye is at? Or we see any heat where that bullseye is at? Tells us we've got an imbalance, which we're not seeing. These boxes are notorious for burning down just the way this one quit. And what causes that is this right here. I don't know why they did this, other than it's cool. God, on camera it looks like this is touching the board. It is not. It's like, what is that tab hanging down on the board? I'm looking at it on the camera. This is a heat activated switch, as we all know. I got to cover it in every video for the guys that don't know. When the amp gets heat soaked enough, eventually through a magic process, heat will wick itself up through the board and heat this part up enough to where the fans might magically turn on in time to save your amplifier. Me personally, I take this white wire and I move it from here to here. And the reason we do that is so when we turn the amp on, oh no, God dang it, I did that mod run wrong. I gotta take this wire and go to here. Oopsie daisy. When we turn the amp on, the fans will kick on. The way this is configured now, the fans will be on all the time. So, my bad. Give me a minute, we'll fix that here. Take the white wire and we'll extend it and we'll hook it up to here. When we turn the switch on, and then the other thing I gotta do is I gotta change this from like to a 4 to like a 6 or an 8 amp fuse. When we turn the amp on, I want the fans to come on. Because I'm assuming that you're only gonna turn your amp on when you're talking, right? You're not just gonna leave it on and let it sit there forever. That's just gay. You want to deplete your batteries or some shit. We want to give it the best head start we can. As soon as I start talking, I want this thing to start cooling itself and have airflow moving across it. I don't want it to try and have the fans kick on after it's been heat saturated for 15-20 minutes. That and these things are notorious because they're not mounted to the body of the amplifier. They're free floating on a piece of fiberglass board. So it's insulated. Insulated. It's insulated. So we'll change out that 4 amp to a 10 amp fuse. Now, be forewarned. You cannot unplug your fans with the amp on. Just unplug it. And yeah, you got a brand new Anderson clip with a little rubber booty to cover up the end of it to keep the dirt out, because we want to keep those connections as clean as possible. That's our goal. All right, let's... God, I'm glad I looked at that closer. Shoot. I'm slipping in my old age. The shit I go through for you guys, I swear. There we go. Now it's square. Well, it's got its little badge of pride. It's earned it. Another one saved from the grave, boys and girls. It's good. It's good. How to put it back in its 15 plastic bags it showed up in. No joke. Gentlemen, I'm done with this one. And I'll move on to the next one. On that note, I want to say thank you. Appreciate y'all tuning in to watch. It means a lot. I feel like I regurgitate a lot of the same knowledge, but then I continuously get told how much the knowledge that I pass on in each one of these videos helps somebody someplace, which I think is cool. I'm grateful. I'm humble. I say thank you, Excess Power. I say thank you, MechMan. Thank you, Bird. Thank you, Coaxial Dynamics. Thanks to all the Patreon subscribers, and a big thanks to all of you. Please take a minute. Come hit up Patreon if you can. Every little penny counts and helps. It allows me to, well, be here and do all of this with all of you guys. So on that note, I say thank you. And on to the next one. I'll see you. Click, click.